Hi guys, this is day 1 of 60 of covering the most important interview questions that can be asked if you are preparing or aspiring to be an AI engineer. Today we will cover the most important question, why RAG is the secret to enterprise AI. So first we will discuss what is the difference between prompting, fine tuning and RAG. Basically, prompting, you can imagine it like this. You have a friend who is a scholar, but he has a short term memory loss, just like Gajani. What happens? The prompt has a context window. Now, you may ask, what is a context window? Basically, it is the token limit or memory limit, like after the token limit is exceeded, it starts to forget information. Like if I'm typing a prompt and the LLM is giving me a response, or if I'm uploading a PDF in my prompt, so all of that combines to a token limit. And if my prompts get bigger and bigger, so what happens is the LLM remembers the starting information and the end information, but the information in middle, it starts to forget it, so a U-shaped curve is formed. So what happens is our prompts get degenerated, and the responses also forgets the information. So now you may ask, why not do fine tuning instead? So some people confuse fine tuning and why it is not the answer. Basically, people think fine tuning is like teaching facts to the LLM, but it is not true. If we do that, it will be a massive blunder. I will explain it with the help of an example. For example, for 2025, there are some HR policies in a company, or there is a financial report of 2025. If I train my model on that, so what will happen if the policies or the financial recordings are changed in future? So my LLM will be trapped in a time capsule, so it will confidently give me wrong answers because it is now trained on the wrong data. Because at present the data may be correct, but in future the data might get outdated. So why should you use fine tuning then? Fine tuning you should only use to dictate a particular format or style of your presentation, basically to prompt the LLM to give you your responses in a particular way, like give it in a particular as you can see the three key points: frozen knowledge, yes, because of time the knowledge keeps on expanding. Hallucinations, yeah, this is for sure confident guesses, confidently giving wrong answers. And fine tuning is like a lot CPU intensive and GPU intensive, and it costs very heavily. Because what happens inside when you are doing fine tuning, actually the weights and biases, you are giving thousands of input A and mapping them to thousands of output B, so the actual weights and biases are getting shifted. So that is fine tuning. So now we will tackle the thing. So what should we do? What is best for entrepreneur AI? So the best thing in the market right now is retrieval augmented generation. So you may ask, what is this then? From our previous example, we had our world class scholar, but with a short term memory loss. So what we are doing now is we are giving him the opportunity to use the search engine. We are enhancing him with the power of search engine. So what happens if I am working in a LLM or chat GPT or prompting something, when I upload a PDF or when I give some resource, so my whole resource is converted into vector embeddings by a embeddings model or a vectorizer. So what happens is the embedding model converts my whole data into a semantic meaning. First of all, it store that embeddings into a database like a Pinecone or Milvius database. So the token limits are not exceeded. It is stored in a separate database. But type a question or ask a question. So what my model does is it finds the most closest, yeah, most closest semantic meaning in my whole database, and it imports only those parts only. It won't upload the full thing. What was happening in prompting is everything you gave into the system was consuming tokens, but in the RAG model only the specific portion that matches the semantic meaning of my question, those things are only getting imported into the prompt, and rest of the things are lying there in the database only. For example, if I have a king, and if I subtract man from it and add woman to it, so it will become a queen. So that's how basically, in simple words, embeddings works. So yeah, as you can see on the screen also, query and search, yes, for sure. It first you type in a query and then it searches the database, and then it maps the context and the LLM, and then it gives you the final answer. So now RAG is actually good for answering particular questions, like for particular year the answer is this, the for particular thing the answer is will be that. But when it comes to a larger picture, we actually need RAG graphs. Now you may ask, what are RAG graphs? Basically, RAG, the first thing is RAG. RAG is good in finding particular haystack information, like finding needle in a haystack. But when it looks to a bigger picture, like Elon Musk is the CEO of SpaceX and he's also the CEO of Tesla. So what where RAG graphs come into play? It builds the actual relationship between the nodes and the edges. It is like converting my whole database into a mind map. So like this person is connected to this by this line means. So the whole things can be summarized. So RAG graphs are very good in giving the overall or generalized information of the whole process. So on the final note, RAG graphs helps the LLM to connect all the information and connect all the dots together, so it can form the better meaning of the whole picture. So this is all for day 1. On day 2, we will discuss more about embedded angles and the cosine similarities and why it is better than Euclidean distance, and the project vertex preview is also coming in the future.